Okay, so welcome back for the application section. So we're going to do some word problems just to kind of talk about how to do the adding. But again, it's try to focus less on the wordiness and try to focus more on the fractions. So Tom and Caswell were shoveling driveways. Okay, Tom or shoveling the driveway. Tom did 3/10 of the driveway. He shoveled 3/10 of it, and Caswell shoveled 2/3 of it. And I want to know how much driveway in total did they shovel. So again, we're going to take 3/10. We're going to add 2/3. So the first step is we need to find a number that both 10 and 3 will go into. So 10, no, 20, no, 30, yep. So let's put down 30 here, 30 here. How do I go from 10 to 30? I multiply by 3, so I'm going to multiply the top by 3. 3 times 3 is 9. How do you get from 3 to 10? Well, I'm going to multiply by 10. So 2 times 10 is 20. And so they have completed 29/30 of the driveway, which is really lazy of them, actually, if you think about it. They could just do that 1/30 and be done with it. So that's example number 1. Let's try another one. Let's say that Shrithika was working on a group project, and Shrithika worked on the project for 3 hours. For 3 and 2/3 of an hour. And Sandavi worked on the same project, her part, for 2 hours. 2 4/5 of an hour, okay? Again, it's not a sign of one doing more work. Maybe it takes a little bit longer, who knows? We want to know what the total hours of work are. So take me through the process. First step, I want to convert them into improper fractions. So 3 times 3 is 9. 9 plus 2 is 11. So I've got 11 over 3. Plus 5 times 2 is 10. 10 plus 4 is 14 over 5. Step 1 is complete. Step 2, got to find a lowest common denominator. What does 3 and 5 go into? 5, 10, no, 15, yes. So turn this to 15 plus 15. How do I get from 5 to 15? I multiply by 3. So I'm going to multiply this by 3. 14 times 3 is 14, 28, 42. How do I get from 3 to 15? I multiply by 5. So I multiply this by 5. So 5 times 11 is 55. 55 and 42. 50 plus 40 is 90. 5 plus 2 is 7. So 97 over 15. Once I've gotten to this point, all I'm doing is turning it back into a mixed number fraction by asking myself how many times does the denominator go into the numerator. So 15 goes into 97. Well, 15, 30, 45, 60, 75, 90. There we go. So that's 6. And what's left over, 97 minus 90 is 7. And we keep the denominator. So 6 and 7/15 of an hour were spent on work. If I asked you how many minutes were spent on work, how could you do that? Well, this would be taking it from an application question to a thinking question. We would take our fractions, 6 and 7/15. We would turn it back into the improper fraction, right? So we've already done that. So we've got 97 over 15. Now, I didn't do this work beforehand, but if I wanted to say how many minutes it was, I would do times, right? So now I'm adding my application into my thinking with, now I'm doing some multiplication. 60 over 1. At this point, I could do some cross-off math, right, to make it easier for myself. 15 goes into 15 once. 15 goes into, oh, that's not working. 15 goes into 15 once. 15 goes into 60 4 times. So now I'm just doing 97 times 4. Mr. Berger's just going to do quickly here. 4 times 7 is 28. 4 times 9 is 36 plus 2, 38. So we've got 388 minutes of time. So a lot of time. Did I do that correctly? Hours, yeah, minutes, yeah, we're all good. Okay, let's do another one. Okay, a different kind of look. We're gonna do both mixed number and proper fraction. So Zubair, he goes to bed 3 hours after dinner. And before he went to bed, he spent 1.5 hours on homework. And he spent 2/3 of an hour on the computer. So how many hours did he spend in total after dinner doing something? So 1.5 plus 2/3. So turn it into a mixed number. 2 times 1 is 2 plus 3. So 3 over 2 plus 2/3. We know that 2 and 3, we're going to count up a 3, 3, 6. That's our winner. 2 times 3 is 6. 3 times 3 is 9. 3 times 2 is 6. 2 times 2 is 4. We're given 13/6. 6 goes into 13 twice. So we get 2 and 1/6 left over. So he used 2 and 1/6 hours on work. Now, if I asked you how many hours does he have left before he has to go to bed, well, you would look at this and say, okay, I've got 2 and 1/6. I'm missing 5/6. So he's got 5/6 of an hour left. Okay, because I'm saying if I added 5 to this, it becomes 6/6, which would make this a 3. So let's try one on your own now, just to see how you're feeling about it. So there's a recipe, and a recipe called for the following. It called for 1 2/3 cups of flour, and it called for 3/4 cups of sugar. Okay. How many cups of dry ingredients did it want? Okay, so that's the focus now. How many cups of dry ingredients did it want? So take a pause, and I'd like you to come back when you've solved it to see if you've done it correctly. Go. Okay, so you're back. Let's take this up. So we've got 1 2/3 plus 3/4. When we turn it into a mixed number fraction, it's 3 times 1 is 3 plus 2 is 5/3 plus 3/4. I ask myself, what does both these numbers go into evenly? The lowest number that they both go into evenly is 12. 3 times 4 is 12. 5 times 4 is 20. 4 times 3 is 12. 3 times 3 is 9. So we have 29 over 12 currently. We'll turn that into a mixed number fraction. 2 times 12 is 24. We've got 5/12 remaining. So it asks for 2 and 5/12 cups for the entire ingredients. So that's the application section. Again, if you focus less on the wordiness and you focus just on the ideas, the what you're trying to get, you notice that when we're looking at adding, we're trying to get to a larger number in total. How many cups were added, that kind of stuff. So we're going to take a stop here. We're going to get back for the thinking section. There's about 2 or 3 questions in the thinking section that will start also leading towards subtraction. Okay, thanks.